So let's start with the program segment with the name test do. It is with the implicit none, the starting command. So you have to declare all of your variables explicitly. Spotlight is here. So I have defined integer ijk, real values x, y, z, and the program says do 10, I varies from 1 to 5, and print I values. So this loop is going to run 5 times if we compile this program and run it. So we have the test run over here. So it prints the values 1 to 5. So let's modify this program to read 5 values and calculate the average value of them. And it means in the do structure, do 10, I varies from 1 to 5. I will read a value x, and then I will store this value in some summation value. So I can say sum plus x, and then I will again read the value x and then update the sum, add to the previous value. So this is like update the sum, and then after this whole summation has been calculated, then I can calculate the average value by defining summation, which is sum of all values, and divide that by 5. And finally, I will be able to print the average value. So with the variable name average. So now with this modification, I have to define a variable for storing the summation, and I have to define a variable to store the average value. These are the modifications that need to be incorporated in this program segment. So let's see whether the logic works or not. So I have to have a variable to store the summation, and I have to have a variable to store the average value. And before the loop, I have to have the summation value empty, because this is the starting point. So sum is initialized as 0. This step is initialization of sum. And this segment, this should be considered distinct in programming. So it is definition of variables or declaration of variables, right? Explicitly. So this is not required. Okay. Okay. So I write here a read statement, read a value x, and here I can write a message. So provide a, for the time being, weight value, right? So 5 values need to be added. So it is confirmed with this statement during the development that this loop is going to run 5 times. So we have got the first value, right? Then I have to calculate the summation, sum plus this x value. And after the loop, the average value can be calculated. So I have the average value calculation as sum of all values from the loop taken one by one and divided by the number of values. For this case, these are 5. And after that, we can print the result. sum of 5 values is equal to the average value. So I can save the program, and in this demonstration, I will ask 5 students to provide their weight values so that we can estimate what's the average weight. Okay, CLS, and compile the program. Okay, so no error has popped up. So let's run it. Testdo.exe. So provide a weight value. So let me volunteer it with my one, 65. So 58, second, 80, okay, 90. So 4 values and the 5th value. No, I like to be a very realistic one. So in this class, I don't see anyone with 100 weight. Okay, please. 60. Okay. So students are not generous even to provide their real value of the weight. I don't think you belong to these values. So the program doesn't ask for more values. So the sum of 5 values, oh, it is not the sum, it should be the average value. So average value is 70.599. So let's make a correction. The average, okay. So the typing mistake, CLS, and one can run that one. So 65, 80, 90, 72, okay, 58. So the sum of the value. So the error, I didn't save the program. The red, uh, the red color is indicative that the program was not saved, right? So again, I have to run. Save and run. Let's do first value, 65, 70, 85, 90, and 73. So the average of 5 values is 76 point something. So the program has been rightfully modified to calculate the average value of 5 weights. Okay, let's stop at this point.